Welcome to the stage, NVIDIA founder and CEO, Jensen Wong.
Welcome to GTC! What an amazing year. We wanted to do this at NVIDIA. So through the magic of artificial intelligence, we're going to bring you to NVIDIA's headquarters. I think I'm bringing you to NVIDIA's headquarters. What do you think? This is where we work. This is where we work. What an amazing year it was, and we have a lot of incredible things to talk about. And I just want you to know that I'm up here without a net. There are no scripts, there's no teleprompter, and I've got a lot of things to cover, so let's get started. First of all, I want to thank all of the sponsors, all the amazing people who are part of this conference. Just about every single industry is represented. Healthcare is here, transportation, retail, gosh, the computer industry. Everybody in the computer industry is here. And so it's really, really terrific to see all of you, and thank you for sponsoring it. GTC started with GeForce. It all started with GeForce. And today, I have here a GeForce 5090. And 5090, unbelievably, 25 years later, 25 years after we started working on GeForce, GeForce is sold out all over the world. This is the 5090, the Blackwell generation, and comparing it to the 4090, look how it's 30% smaller in volume. It's 30% better at dissipating energy and incredible performance. Hard to even compare, and the reason for that is because of artificial intelligence. GeForce brought CUDA to the world. CUDA enabled AI, and AI has now come back to revolutionize computer graphics. What you're looking at is real-time computer graphics, 100% path traced. For every pixel that's rendered, artificial intelligence predicts the other 15. Think about this for a second. For every pixel that we mathematically rendered, artificial intelligence inferred the other 15. And it has to do so with so much precision that the image looks right, and it's temporally accurate, meaning that from frame to frame to frame, going forward or backwards because it's computer graphics, it has to stay temporally stable. Incredible. Artificial intelligence has made extraordinary progress. It has only been 10 years. Now, we've been talking about AI for a little longer than that, but AI really came into the world's consciousness about a decade ago. Started with perception AI, computer vision, speech recognition, then generative AI. The last 5 years, we've largely focused on generative AI, teaching an AI how to translate from one modality to another modality, text to image, image to text to video, amino acids to proteins, properties to chemicals, all kinds of different ways that we can use AI to generate content. Generative AI fundamentally changed how computing is done. From a retrieval computing model, we now have a generative computing model. Whereas almost everything that we did in the past was about creating content in advance, storing multiple versions of it, and fetching whatever version we think is appropriate at the moment of use. Now, AI understands the context, understands what we're asking, understands the meaning of our request, and generates what it knows. If it needs, it'll retrieve information, augments its understanding, and generate answer for us. Rather than retrieving data, it now generates answers. Fundamentally changed how computing is done. Every single layer of computing has been transformed. The last several years, the last couple, 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about how to answer or how to solve a problem. And it can plan an action. It can plan and take action. It can use tools because it now understands multimodality information. It can go to a website and look at the format of the website, words and videos, maybe even play a video. Learns from what it learns from that website, understands it, and come back and use that information, use that newfound knowledge to do its job. Agentic AI. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next wave is already happening. We're going to talk a lot about that today. Robotics, which has been enabled by physical AI. AI that understands the physical world. It understands things like friction and inertia, cause and effect, object permanence. When some corner doesn't mean it's disappeared from this universe. It's still there, just not seeable. And so that ability to understand the physical world, the three-dimensional world, is what's going to enable a new era of AI we call physical AI, and it's going to enable robotics. Each one of these phases, each one of these waves opens up new market opportunities for all of us. It brings more and new partners to GTC. As a result, GTC is now jam-packed. The only way to hold more people at GTC is we're going to have to grow San Jose. And we're working on it. We got a lot of land to work with. We got to grow San Jose. So that we can make GTC, I have to just, as I'm standing here, I wish all of you could see what I see. And we're in the middle of a stadium. And last year was the first year back that we did this live. And it was like a rock concert. And it was described, GTC was described as the Woodstock of AI. And this year it's described as the Super Bowl of AI. The only difference is everybody wins at this Super Bowl. Everybody's a winner. And so every single year, more people come because AI is able to solve more interesting problems for more industries and more companies. And this year, we're going to talk a lot about agentic AI and physical AI. At its core, what enables each wave and each phase of AI, three fundamental matters are involved. The first is how do you solve the data problem? And the reason why that's important is because AI is a data-driven computer science approach. It needs data to learn from. It needs digital experience to learn from, to learn knowledge and to gain digital experience. How do you solve the data problem? The second is how do you solve the training problem without human in the loop? The reason why human in the loop is fundamentally challenging is because we only have so much time, and we would like an AI to be able to learn at superhuman rates, at super real-time rates, and to be able to learn at a scale that no humans can keep up with. And so the second question is, how do you train the model? And the third is, how do you scale? How do you find an algorithm whereby the more resource you provide, whatever the resource is, the smarter the AI becomes? The scaling law. Well, this last year, this is where almost the entire world got it wrong. The computation requirement, the scaling law of AI is more resilient and, in fact, hyper-accelerated. The amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. And let's reason about why that's true. The first part is let's just go from what the AI can do. Let me work backwards. Agentic AI, as I mentioned, at this foundation is reasoning. We now have AIs that can reason, which is fundamentally about breaking a problem down step by step. Maybe it approaches a problem in a few different ways and selects the best answer. Maybe it solves the same problem in a variety of ways and ensure it has the same answer, consistency checking. Or maybe after it's done deriving the answer, it plugs it back into the equation, maybe a quadratic equation, to confirm that, in fact, that's the right answer, instead of just one shot blurbing it out. Remember, 2 years ago, when we started working with ChatGPT, a miracle as it was, many complicated questions and many simple questions, it simply can't get right, and it's understandably so. It took a one shot, whatever it learned by studying pre-trained data, whatever it saw from other experiences, pre-trained data, it does a one-shot, blurps it out, like a savant. Now, we have AIs that can reason step by step by step, using a technology called chain of thought, best of n, consistency checking, a variety of different path planning, a variety of different techniques. We now have AIs that can reason, break a problem down, reason, step by step by step. Well, you could imagine, as a result, the number of tokens we generate, and the fundamental technology of AI is still the same. Generate the next token, predict the next token. It's just that the next token now makes up step one. Then the next token after that, after it generates step one, that step one has gone into the input of the AI again as it generates step two, and step three, and step four. So instead of just generating one token or one word after next, it generates a sequence of words that represents a step of reasoning. The amount of tokens that's generated as a result is substantially higher, and I'll show you in a second. Easily 100 times more. Now, 100 times more, what does that mean? Well, it could generate 100 times more tokens, and you can see that happening, as I explained previously. Or the model is more complex. It generates 10 times more tokens, and in order for us to keep the model responsive, interactive, so that we don't lose our patience waiting for it to think, we now have to compute 10 times faster. And so 10 times tokens, 10 times faster, the amount of computation we have to do is 100 times more easily. And so you're going to see this in the rest of the presentation. The amount of computation we have to do for inference is dramatically higher than it used to be. Well, the question then becomes, how do we teach an AI how to do what I just described? How to execute this chain of thought? Well, one method is you have to teach the AI how to reason. And as I mentioned earlier, in training, there are two fundamental problems we have to solve. Where does the data come from? Where does the data come from? And how do we not have it be limited by human in the loop? There's only so much data and so much human demonstration we can perform. And so this is the big breakthrough in the last couple of years. Reinforcement learning, verifiable results. Basically, reinforcement learning of an AI as it attacks or tries to engage solving a problem step by step. Well, we have many problems that have been solved in the history of humanity where we know the answer. We know the equation of a quadratic equation, how to solve that. We know how to solve a Pythagorean theorem, the rules of a right triangle. We know many, many rules of math and geometry and logic and science. We have puzzle games that we could give it, constraint type of problems like Sudoku. Those kind of problems, on and on and on. We have hundreds of these problem spaces where we can generate millions of different examples and give the AI hundreds of chances to solve it step by step by step, as we use reinforcement learning to reward it as it does a better and better job. So as a result, you take hundreds of different topics, millions of different examples, hundreds of different tries, each one of the tries generating tens of thousands of tokens. You put that all together, we're talking about trillions and trillions of tokens in order to train that model. And now with reinforcement learning, we have the ability to generate an enormous amount of tokens. Synthetic data generation, basically using a robotic approach to teach an AI. The combination of these two things has put an enormous challenge of computing in front of the industry. And you can see that the industry is responding. This is, what I'm about to show you is Hopper shipments of the top 4 CSPs. The top 4 CSPs. They're the ones with the public clouds. Amazon, Azure, GCP, and OCI. The top four CSPs, not the AI companies, that's not included, not all the startups, not included, not enterprise, not included, a whole bunch of things not included, just those 4. Just to give you a sense of comparing the peak year of Hopper and the first year of Blackwell, okay? The peak year of Hopper and the first year of Blackwell. So you can kind of see that, in fact, AI is going through an inflection point. It has become more useful because it's smarter, it can reason. It is more used. You can tell it's more used because whenever you go to ChatGPT these days, it seems like you have to wait longer and longer and longer, which is a good thing. It says a lot of people are using it with great effect. And the amount of computation necessary to train those models and to inference those models has grown tremendously. So in just 1 year, and Blackwell has just started shipping, in just 1 year, you could see the incredible growth in AI infrastructure. Well, that's being reflected in computing across the board. We're now seeing, and this is, the purple is the forecast of analysts about the increase of capital expense of the world's data centers, including CSPs and enterprise and so on, the world's data centers through the end of the decade, so 2030. I've said before that I expect data center build out to reach $1 trillion, and I am fairly certain we're going to reach that very soon. 2 dynamics is happening at the same time. The first dynamic is that the vast majority of that growth is likely to be accelerated, meaning we've known for some time that general purpose computing has run its course, and that we need a new computing approach. And the world is going through a platform shift from hand-coded software running on general purpose computers to machine learning software running on accelerators and GPUs. This way of doing computation is at this point past this tipping point. And we are now seeing the inflection point happening, the inflection happening in the world's data center buildouts. So the first thing is a transition in the way we do computing. Second is an increase in recognition that the future of software requires capital investment. Now, this is a very big idea. Whereas in the past, we wrote the software and we ran it on computers, in the future, the computer is going to generate the tokens for the software. And so the computer has become a generator of tokens, not a retrieval of files. From retrieval-based computing to generative-based computing, from the old way of doing data centers to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one job only, generating these incredible tokens that we then reconstitute into music, into words, into videos, into research, into chemicals or proteins. We reconstitute it into all kinds of information of different types. So the world is going through a transition in not just the amount of data centers that will be built, but also how it's built. Well, everything in the data center will be accelerated. Not all of it's AI. And I want to say a few words about this. You know, this slide is genuinely my favorite. And the reason for that is because for all of you coming to GTC, all of these years, you've been listening to me talk about these libraries this whole time. This is, in fact, what GTC is all about, this one slide. And in fact, a long time ago, 20 years ago, this is the only slide we had. One library after another library after another library. You can't just accelerate software, just as we needed an AI framework in order to create AIs, and we accelerate the AI frameworks. You need frameworks for physics and biology and multi-physics and all kinds of different quantum physics. You need all kinds of libraries and frameworks. We call them CUDA-X libraries, acceleration frameworks for each one of these fields of science. And so this first one is incredible. This is CuPy numeric. NumPy is the #1 most downloaded Python library, most used Python library in the world. Downloaded 400 million times this last year. cuLitho is and CuPy numeric is a zero change drop-in acceleration for NumPy. So if any of you are using NumPy out there, give CuPy numeric a try. You're gonna love it. cuLitho, a computational lithography library. Over the course of 4 years, we've now taken the entire process of processing lithography, computational lithography, which is the second factory in a fab. There's the factory that manufactures the wafers, and then there's the factory that manufactures the information to manufacture the wafers. Every industry, every company that has factories will have 2 factories in the future. The factory for what they build and the factory for the mathematics, the factory for the AI. Factory for cars, factory for AIs for the cars. Factory for smart speakers and factories for AI for the smart speakers. And so cuLitho is our computational lithography, TSMC, Samsung, ASML, our partners Synopsys, Mentor, incredible support all over. I think that this is now at its tipping point. In another 5 years' time, every mask, every single lithography will be processed on NVIDIA CUDA. Ariel is our library for 5G, turning a GPU into a 5G radio. Why not? Signal processing is something we do incredibly well. Once we do that, we can layer on top of it AI for RAN, or what we call AI RAN. The next generation of radio networks will have AI deeply inserted into it. Why is it that we're limited by the limits of information theory? Because there's only so much information spectrum we can get, not if we add AI to it. cuOpt, numerical or mathematical optimization. Almost every single industry uses this when you plan seats and flights, inventory and customers, workers and plants, drivers and riders, so on and so forth, where we have multiple constraints, a whole bunch of variables, and you're optimizing for time, profit, quality of service, usage of resource, whatever it happens to be. NVIDIA uses it for our supply chain management. cuOpt is an incredible library. It takes what would take hours and hours, and it turns into seconds. The reason why that's a big deal is so that we can now explore much larger space. We announced that we are going to open source cuOpt. Almost everybody is using either Gurobi or IBM CPlex or FICO. We're working with all 3 of them. The industry is so excited. We're about to accelerate the living daylights out of the industry. Parabricks for gene sequencing and gene analysis. MONAI is the world's leading medical imaging library. Earth-2 multi-physics for predicting in very high resolution local weather. cuQuantum and CUDA-Q. We're going to have our first quantum day here at GTC. We're working with just about everybody in the ecosystem, either helping them research on quantum architectures, quantum algorithms, or in building a classical accelerated quantum heterogeneous architecture. And so really exciting work there. equivariance and Q-tensor for tensor contraction, quantum chemistry. Of course, this stack is world famous. People think that there's one piece of software called CUDA, but in fact, on top of CUDA is a whole bunch of libraries that's integrated into all different parts of the ecosystem and software and infrastructure in order to make AI possible. I've got a new one here to announce today. QDSS, our sparse solvers, really important for CAE. This is one of the biggest things that has happened in the last year. Working with Cadence and Synopsys and Ansys and Dassault and all of the systems companies, we've now made possible just about every important EDA and CAE library to be accelerated. What's amazing is until recently, NVIDIA's been using general purpose computers running software super slowly to design accelerated computers for everybody else. And the reason for that is because we never had that software, that body of software optimized for CUDA until recently. And so now our entire industry is going to get supercharged as we move to accelerated computing. QDF, a data frame for structured data. We now have a drop-in acceleration for Spark and drop-in acceleration for Pandas. Incredible. And then we have Warp, a library for physics that runs in a Python library for physics for CUDA. We have a big announcement there. I will save it in just a second. This is just a sampling of the libraries that make possible accelerated computing. It's not just CUDA. We're so proud of CUDA. But if not for CUDA and the fact that we have such a large installed base, none of these libraries would be useful for any of the developers who use them. For all the developers that use them, you use it because, one, it's going to give you incredible speed up. It's going to give you incredible scale up. And two, because the install base of CUDA is now everywhere. It's in every cloud. It's in every data center. It's available from every computer company in the world. It's literally everywhere. And therefore, by using one of these libraries, your software, your amazing software can reach everyone. And so we've now reached the tipping point of accelerated computing. CUDA has made it possible. And all of you, this is what GTC is about, the ecosystem. All of you made this possible. And so we made a little short video for you. Thank you.
To the creators, the pioneers, the builders of the future, CUDA was made for you. Since 2006, 6 million developers in over 200 countries have used CUDA and transformed computing. With over 900 CUDA-X libraries and AI models, you're accelerating science, reshaping industries, and giving machines the power to see, learn, and reason. Now, NVIDIA Blackwell is 50,000 times faster than the first CUDA GPU. These orders of magnitude gains in speed and scale are closing the gap between simulation and real-time digital twins. For you, this is still just the beginning. We can't wait to see what you do next.